Welcome to the Heat Treat Podcast, sponsored by Matza, Creo, and Super Systems.
Welcome back to the Heat Treat Podcast, where we dive into the worlds of heat treating, innovation, and the leaders shaping our industry. Today's guest is someone who combines deep technical expertise with visionary leadership in the vacuum furnace world. Trevor Jones is the president of Solar Manufacturing, one of the most respected names in the vacuum furnace design and engineering, with a background in both mechanical and electrical engineering. Trevor has grown from intern to the industry leader, helping shape the future of heat treating through today's technology, research, and real-world application. Trevor, it's an honor to have you here. Welcome.
Carlos, thank you. It is an honor to be here. I appreciate the invitation.
So, Trevor, we met back in Columbus last year, and I attended one of Trevor's lectures regarding a new project that they have. And, you know, I can tell the audience that Trevor is a great engineer, very passionate about what he does. So I was thrilled to have him on the podcast and ask him a bunch of questions. But first of all, Trevor, let's start with your background. From intern at Solar Atmosphere to president of Solar Manufacturing. It's quite a journey. Tell us a little bit about your path and how it shaped your approach to leadership in the heat treat industry.
Oh, well, thank you, Carlos. My path has been a very interesting one. It's a path that involves a lot of involvement with our family business. And it really goes back to my grandfather founding a manufacturing of a furnace company called VFS. And from VFS spawned Solar Atmospheres, the commercial heat treating company. And from Solar Atmospheres came Solar Manufacturing. And Solar Manufacturing, we are the division of Solar Atmospheres that actually designs and builds the furnaces themselves. So earliest memories I have are coming into Solar Atmospheres as a toddler with my dad.
Really?
You know, we had no back shift. So he would come in on nights and weekends, and I'd come in and I would just be amazed at the noises, the sounds that you would hear, and just be enamored by what my dad was doing with these furnaces. And I could hardly even know what he was doing at the time, but just very interesting. So that was some of my early experiences. I started out pulling weeds in the gardens. I got to be honest, that job didn't last long, though. I got tired of that very quickly, pulling weeds at the company business. Interestingly enough, in high school, I did some odd jobs and I was a landscaper. And now I actually enjoy landscaping, but I don't want to get off track too much here. So I worked at Solar Atmospheres as a basically summer job, doing odds and ends, starting from sweeping floors, cleaning furnaces, anything that was a minuscule task I had to do. And that was fun. You got to start somewhere, right? And from there, I went to Penn State University when I graduated high school. And at Penn State, I got a degree in electrical engineering, an associate's degree in technology, and a mechanical engineering degree as well. And I chose those degrees, Carlos, because I felt that what I was preparing myself was the vacuum furnace technology business, which uses those two educations very deeply, aside from material science, obviously, for the vacuum heat treating. Once I graduated, I graduated in 2004, and I immediately became a project engineer at Solar Atmospheres, working in the research and development department, really concentrating on process development than anything else. And with that process development, how to make the furnaces do what they need to do in order to make that process work. From there, I learned a lot. Learned very much about how furnaces work and why, and it was a very great time for me of learning and education. My grandfather, he mentored me. I learned a lot from him, and a lot from a lot of people here. We have a lot of good people here at Solar Atmospheres and Solar Manufacturing, but really from my grandfather. He taught me a lot about furnaces. He really took me under his wing, so to speak, and taught me what to do. So it is a family business. I have a brother. His name is Jamie Jones. Jamie is the president of Solar Atmospheres at one of our facilities. And we have other presidents as well at the other facilities across United States. But I felt that we needed somebody to take in the solar manufacturing division, as my grandfather was getting to the point where he's never going to retire, let's be honest. He's 90 years old now, and the man still comes in every day. So it keeps him going. but I saw that we needed somebody there to take that company and continue it and expand it. So that's where I find myself today, is at Solar Manufacturing, leading that company, and my transition from pulling weeds to leading the manufacturing company, so to speak.
So I got a question for engineers. Your background is on mechanical and electrical, and then you understood process by working on a heat treat. But what would be easier for a metallurgist to learn mechanics and electricity, or for a mechanical engineer or an electrical engineer to learn process? I feel the same because I'm an industrial engineer, and I learned metallurgy through the heat treat, but it's quite hard. But what's your opinion on that one? If you were to go on material science and you have to learn mechanical and electric.
So I guess if I were to say, what is easier transition, I guess is the question, from materials into
Yeah.
electrical mechanical, or mechanical and electrical into more of a materials type of technology. Is that correct?
That's correct.
Yeah. So that's a great question, Carlos. And I guess speaking from my own experience, it was the electrical mechanical learning more of the materials. I was hands-on materials learning, just being here doing processing. I really did a lot of work with carburizing and nitriding. So we had metallurgists here that taught me on the job how to learn materials. So I really knew nothing about materials or processes, really, for that matter. So since I came from the background from mechanical, electrical, and learned the processing or materials side of thing, I have to say that was easier. That's not to say that it would not go as easily the other way as well, though.
It was less challenging, not easier.
It was.
Right.
I kind of picked it up quick. Yeah, I would say it was. It was sort of in my blood, so to speak, the material side and the processing side.
All right. So let's get to technology and vacuum technology evolution and furnace challenges, since you design furnaces. So you've been in the field during a time of significant evolution in the vacuum heat treating technology world. What do you think? What are the most of the notable advances you have seen over the years?
I would say that some of the most advances I've seen in the vacuum furnaces over the years, and my experience really is only about 25, 30 years or so in really getting into the nuts and bolts of vacuum furnaces, has got to be the technology, Carlos. It's the control systems.
Controls.
And I don't think that's anything that's going to be a surprise for anybody to hear. The vacuum furnace that we build and design is a batch vacuum furnace. That's what we do. It's a very mature product. There's not a whole lot of mechanical changes that are going on with the vacuum furnaces themselves. There are small advances in certain aspects of the furnace, but you're always going to have roughing pumps, booster pumps, diffusion pumps. They're basically the same. They haven't changed much over the years. Booster pump will give you 99.99% of the atmosphere out of a vacuum. That's been the way it's been since the 1930s and 40s. However, there's other challenges with the control systems. Technology today is just advancing at lightning speed. So things like SCADA system, supervisory control and data acquisition, that's been advancing a lot, allowing users to access the furnace remotely and see what's going on if they want to from the couch of their living room and see what the furnace is doing. Or just they're in a control room at the company. Maybe there's a room with screens that show all the furnaces, what they're doing at any given time, and you need to intervene with something on that furnace. That's something that's advancing these days. Preventative maintenance, predictive maintenance. What's going to go wrong with this furnace? Is there a certain components that are heating up that over time? So you might have thermal imaging equipment on your furnace to see, oh, that motor, it's getting hot. Maybe we need to think about changing that out. Or it's vibrating more than it should. Maybe we should be changing out that motor before it fails and we're down for an unexpected amount of time. Quenching technology has also changed over the years. It's gone from an atmospheric quench up to 20 bar plus quench. 20 bar being 20 times the atmospheric pressure. More gas you have in the furnace, faster you can cool off parts. The size of the motors have gone up. Our furnaces today, we have up to 600 horsepower motors for cooling. So quenching technology has also advanced but they're not as advancing as fast as control systems are really advancing.
Right.
That's for sure.
Now, solar manufacturing is known for custom-built vacuum furnaces. What are some of the key challenges when designing system tailored to very specific customers and applications? And how do you balance the need for precision and customization with timelines and complexity? Because you
Yeah.
have to deliver, right?
Yes. So solar manufacturing is,
If I may, I do believe that that's like the biggest challenge of furnace manufacturing to balance precision, customization, and timeline. Of course, budget, but I mean that's pretty much what you handle as a business, right?
yes, you're absolutely right. We are certainly known for our custom furnaces and some of our large custom furnaces as well. Our largest furnace is 48 feet in diameter vacuum furnace. It's a very large custom furnace, obviously. And there's a lot of challenges that come with that, especially when they come from outside our own company, outside of the Solar Atmospheres affiliate companies. If there's an aerospace company that wants you to build this custom furnace, they tend to come with you with very unique specifications that you need to adhere to. And it could be the detail, Carlos, of something that I only use component XYZ. I won't name a brand.
Right.
So therefore, you can only use that component in your control system or in your control panel. Well, that's a whole design change for us.
It
We
is.
have to get a lot of engineering involved in this, understand what that component now is and what it's due, and how we're going to integrate that now into our furnace. So I think the customer specifications are certainly a challenge. They may have some very strict health and safety regulations on their furnace. Might be some electrical enclosures. They might want to separate 120 volts from 480 volts in completely different control panels. So we have to design to that rather than putting that all into one panel. That's just another example. Other than that, customers come to us with requirements like you have to meet a certain quench rate. So that can be a challenge as well, because we may not have that part to put in a furnace similar to it and see how quickly it quenches. So there's a lot of thermodynamic calculations and assumptions and previous history that you have to take into account to say, I think we can do this. I'm willing to take the challenge and take this project on. So I would say some things like that certainly make custom-made furnaces very challenging. And as you also briefly mentioned there, budgeting for those can be also very challenging, because sometimes you don't know what you're getting into when you're creating that budget for that furnace until you really get deep into the project itself and realize we're gonna need some extra parts or some extra engineering hours for this that we didn't anticipate. So you have to budget, not quoting yourself out of the job, but not underselling yourself either. So that certainly got its complexity with it as well.
And also you gotta make it on time. I mean, they're always in a hurry to get their furnace, right?
Oh my gosh, yes. Delivery. And that's a big thing. And it's becoming more and more important as we're seeing. And in some sense, Carlos, I feel like we're with these tariffs, for example, and things being held up, we're starting to see some delays.
Yeah, on the supply chain, you mean?
I'm sorry?
On the supply chain, you mean?
Supply chain, yeah, absolutely. It's almost as if we're back to the COVID days in some ways. Not as bad, but almost. Just trying to get some material in that we really desperately need. And lead times, they're starting to creep up again, and prices are creeping up again. So that's challenging. That's hurting deliveries, and certainly the customer wants their furnace as soon as possible. Solar manufacturing, as I mentioned, we're well known for our custom furnaces. However, we do have a speculation program as well. We have 3 different models that we build the chambers, completely build the furnaces on speculation that they will eventually sell. And what they sell on is delivery. So they're not customizable to a high degree. We allow a few options on them, but we build them knowing that eventually we're going to have somebody come in and buy them because they desperately need a furnace very quickly.
And now that you mentioned all of the challenges that you have, just would like to talk a little bit about leadership and your role from engineering to president. Now that you're not only designing the furnaces, I mean, you have to manage the company, you have to manage the team, you have to manage the customers, budgets, and that. But transitioning from engineering to management isn't always easy, especially when it's a family company. What were some of the biggest personal challenges in making this shift, and how do you continue to stay close to the technical side while running the company, because I know that you're a very devoted engineer. But when you become a president, uh, 80% of the job is tracking budgets, relationships, keeping HR, supply chain, and you kind of lose focus on the spirit of what engineering is on the application itself. Can you relate to that?
However, I can certainly relate to that. And you hit the nail on the head, Carlos. It's hard to let go of the technical challenges. And as soon as I feel like I'm starting to let go of those technical challenges, I tend to gravitate right back to that because it's where my passion really is, deep down in my roots. However, management is extremely important and leadership is very important to the success of the company and its growth as well. So I ground myself and realize that I also need to focus on some of these management skills, dealing with personnel issues, dealing with budget issues, learning, a lot of learning about business that I never really was exposed to, finances, operations, customer relationships, all these things that as an engineer, you may have a little bit of exposure to, but when you're a manager, it's your number one focus. And to solve a problem, technically, you use equations to do that. But solving, say, operations issues, there's not really equations to solve some operation issues. They span different departments, and you got to really dig in and understand what each department is doing the best that you can to try and solve that problem. There's no equations really for that.
And we're in a business which human labor is still something that we must have. It's very, I wouldn't say impossible, but it's very hard to automate the manufacturing of a furnace, right? You need skilled labor, and they need to see they need to know what they're doing, and you need to train them. Also with engineers, there's a bunch of engineers, but there are very seldom furnace engineers. They can be mechanical engineers, electrical engineers, but there are not many furnace, well, in your case, vacuum furnace engineers, which is a total different niche. But let's talk about the workforce and the talent. What challenges are you seeing attracting and retaining talent in our industry, particularly in engineering and skilled trades, maybe technicians, right, for PLC technicians or control technicians? And from your perspective, what are the major trends shaping the heat treating industry today, technologically and commercially, for those people to stay in?
So to address the first part of your question, it is difficult finding and recruiting skilled technicians and trade shop labor, we'll say, that can do welding and plumbing.
Precision welding and precision plumbing, right?
Precision, you're absolutely right. And precision is a key word there, Carlos, because these are vacuum tight connections they're making. We test these vacuum connections with a helium mass spectrometer. So the tiny atom size of a helium molecule cannot go through these little cracks that they're brazing or welding. So yes, precision is absolutely right about that. And that is difficult to find. And also people that are skilled at wiring and doing interconnect wiring from the control panel and visualizing how it should look from the conduit, the way it's run most efficiently to the furnace itself, and how the power supply for the furnace should be connected to the furnace with the cables. That's all very skilled work, and that is very difficult to find these days. We tend to go after a lot of trade schools if we need some help. There's a lot of trade schools around us that we go after to try and find some of that young talent. And we have to find young talent because there's a lot of people that are retiring as well. We're losing a lot of knowledge in both our trade skills and in engineering as well. And this industry is a very niche industry, the vacuum furnaces. So finding people that have that experience is extremely difficult to find. You probably won't find it. We find ourselves having to train and educate more than anything else when we find the right person for those jobs. So it is a challenge. We do as best we can to find people to fill those voids. One of the most difficult positions I'd say to fill, Carlos, would be our field service engineers.
Yes, that's a tough one.
Yes, exactly. Those are the individuals that they go out in the field, either when you're done building the furnace, it has to be commissioned in the field, and then you send a field service engineer to commission that furnace. And they could travel anywhere from a week to a month and be on the road. That's a long time for some people to be on the road. And not only that, they have to be the experts on that furnace and the company's eyes and ears, and the company's, it's who the company is, the representative from the company. So it's a very important role. We have some great field service engineers. It's a position we're always looking to expand on. As we ship more and more furnaces, that side of the business is only going to grow, because now we can offer service contracts, preventive maintenance contracts, and things like that. So field service is very difficult to fill.
And when you mention when you ship a furnace, I mean, furnaces, their life, it's pretty long if you well maintain them. But as we mentioned today, controllers are evolving at a much faster rate. So there's going to be a point that controls have to be updated and not the whole system, and you're going to need to do all that on the field, right? And a side question: do you envision a furnace in the near future that can just be shipped plug and play, or that will be, very optimistic from my side?
Well, I think the closest to plug and play would be some of our speculation models. Really, the plug and play is the water, the gas, and the power. Those are the only three connections you need. There's no disassembling the furnace and reassembling it. You just need to hook up those three utilities to the furnace and you're ready to go.
Well, and what about the upgrades?
Oh, I'm sorry about the upgrades. So upgrades for the furnace, is that a plug and play? I guess, is that the question?
No, I mean, it's very difficult to do an upgrade on the field, especially when you're rewiring an old furnace that the controllers might not be compliance with themselves, because of the latest version or something like that. I mean, that's hard to upgrade a furnace on the field. It takes a lot of labor, and sometimes the prints are updated or even changed.
Yeah. Yes, you're right, Carlos. For upgrading an existing control panel is very tough. And sometimes we find it's actually better just to start from scratch with a new control panel.
Totally. I will agree 100% with that.
It's less downtime at the end of the day, right, for the end user. Rather than taking the furnace down, taking out all the antiquated equipment, rewiring things, installing new programmers, displays, HMIs, recorders, so on and so forth, PLCs. Just take out the old cabinet, have a new cabinet ready to go, and have that cabinet as ready as it can possibly be with drawings that are hopefully as up to date as they are. But at least you have time then to ask questions about certain ways the schematics might be worded or constructed, and you're not trying to figure out things on the fly, because every minute or every hour that furnace is down, that's costing your customer money, right? As we call them, these furnaces are like taxis. Whenever the light is not on, and it's not collecting money, so they want to get that furnace back up as quickly as possible. And what we found is just start over, just get a new control panel, rip out the old one, install the new one.
And that may have like a higher entry ticket. It might look higher on the quote, but if you get a new panel fully to go, fully tested in your shop, and you ship it, you're gonna clear so much headaches that you're gonna find on the field, because something is gonna fail, you're gonna miss something, and we're gonna go right now to supply chain and tariffs, right? And you're gonna miss like a very special material, or something that is gonna be suddenly 16 weeks to deliver, right? And so let's talk about tariffs, supply chain, and how you're dealing with those. We have seen how global supply chain disruptions and tariffs have affected manufacturing, especially when you have to deliver on time and on budget. How is solar manufacturing adapted these pressures nowadays? Well, we're talking about trade war. And what lessons have you learned about resilience and sourcing that you can share with the audience?
Yeah, so this is a very challenging time.
It is.
As I mentioned earlier, it's almost like COVID all over again. Lead times and prices are very unpredictable and very volatile as well. Just as one example, a material that's used in vacuum furnaces a lot is a material called molybdenum. We call it moly.
Moly.
A lot of that comes from overseas. And we recently received a shipment, and there is a tariff charge put on that shipment. And we had no idea that, well, we had an idea it would be put there, but we didn't catch it early enough, and it's not in the budget. So now we have to absorb a lot of that extra cost. We can't just pass those on to customers as we would like to. We won't do that, at least in that one shipment. Carlos, I think I'd like to start over with this question, actually, if you don't mind. I feel
I
like
do.
I'm kind of fumbling on this one.
I don't mind. So let's go back. Trevor, we have seen how global supply chain disruptions and tariffs have affected manufacturing. How has solar manufacturing adapted to these pressures that we're seeing nowadays with trades and tariffs? And what lessons have you learned about resilience and sourcing that you can share with the audience and other manufacturers?
Right. Yeah. Tariffs have been very difficult to predict where they're going. This is an extremely volatile time. And Carlos, I'd like to say by the time this podcast is aired or is viewed in a couple months from now, that these tariffs are gone. But we don't know. Nobody knows.
Well, at least we're not wearing masks like in COVID right now.
Yes.
Right.
Isn't that the truth?
Right.
That's the one good thing about this. But short of wearing masks, it's just like COVID all over again. It's exactly the same thing. And with COVID, you kind of saw where things were sort of going over time. It was a delay. It took a while to get over it. But with these tariffs, as I mentioned, it's a day by day roller coaster. And we don't know what's coming the next day. So to try to hedge off some of those issues that we are seeing, we try to put some contingencies and budgets just to try and cover ourselves. We know something is coming our way. So we might put a couple of extra percentage points in, say, a material like molybdenum, for example. We received a recent shipment of that, and there was a significant tariff charge on it that we didn't fully account for. We can absorb some of that, but we can't absorb all of that. And I don't think there's a manufacturer in at least North America, United States, that can absorb all of that forever. Eventually, everybody's going to have to increase costs. And that's going to cause another issue with inflation. Like I feel like we were just getting over inflation, and now it feels like it's coming back again. So we're trying to do things like that. We're trying to find new sources of materials, electrical components, but it's hard to change too. We designed our furnaces, our control systems around certain components. So to just switch without vetting out something is a bit of a risk as well. So we have to be certain that if we do find another source that avoids a tariff, for example, that's going to work for us and not compromise our product or our customers' quality of their product as well.
And I have talked to other manufacturers, and we just talked about the supply chain, but but also pricing gets very dynamic. When you submit a proposal, and suddenly you have like a tariff, and you cannot stand the price for the quote for more than 30 days. And to approve on big corporations an asset like a furnace, it takes months. So you send a quote. Suddenly you have tariffs and dynamics on costings and budgetings and pricings, delivery times as well. And suddenly you have to give POs back because you just cannot commit to the pricing because of the dynamic market. Any feedback on how to handle that?
Yeah, that's always a tough one, Carlos, because these quotes, especially for these custom furnaces, the customer could sit on it for months. There's projects we work on for a year or more. And it is an opportunity we have. We have quote validities on our quotes, and we have shortened those quote validities to try and capture if a cost increase goes up. But that's also becomes a difficult conversation sometimes with the customer as well, when you have to increase your cost significantly more than what even they're expecting. But at the same time, you have to protect yourselves as well. It can get to a point where you might have to walk away from a job. Maybe the job just isn't right for you because you look at the bottom line and say, I'm sorry, we can't do this. It's just not financially makes sense for our company to do this at this time. Fortunately, we're very busy right now. Actually, this is our shop floor behind us, and we got furnaces all over the place. So we're in a time right now where we can be a little bit selective with what we're accepting to quote and to take on. But these times don't always last. There are downtimes in the economy where you have to get hungry, and you might have to get down and really fight for work, and maybe you're going to take some lower margins just to get that job.
I'm glad you're very busy because not many people are very busy right now. So I'm glad you live the dream and, looking for the future ahead, preparing the supply chain. Now let's talk a little bit on the human side. I mean, I've been into your facilities with the MTI. I was there a couple. You're in Pennsylvania, right?
Yes, I am.
Yes, I visit both facilities, Atmospheres and manufacturing, and I must say it's a very state of the art, very organized, clean shop. A lot of engineers, state of the art. I just want to state that to the audience, right? What you're looking in the picture in the background is actually true. I mean, it's so. But now we are in a very niche industry, right? And we're competing for talent with other industries, big corporations, a little more sexier or fancier, like Google or Facebook or Amazon. But let's go to an advice for the next generation, because you're a very young president. I mean, you're very well prepared, and I think you're doing a fantastic job. But you know, you are kind of the next generation, but you also need to be advising the next generation, the guys that are looking to go after mechanical or material science or business. But and you have been deeply involved in the education and leadership through the ASM and the MTI. But what advice would you give to the young engineers or professionals entering the heat treat industry today, or if they're not sure that they want to enter this industry and they're applying for other jobs? What can you tell them if you could?
Yeah, I tell them a couple things, Carlos. Speaking from the solar manufacturing side of our business, one thing that is exciting about vacuum furnaces, vacuum furnace heat treating, there's a lot of sciences that are involved. It's electrical engineering, it's mechanical engineering, it's materials engineering, it's chemical engineering. There's probably others I'm missing. But
Computer
there's so many
science,
sciences.
computer science now.
Absolutely, you're right. Computer sciences, guys that are going to be programming, guys or gals that are going to be programming programmable logic controllers and HMIs. There is so much involved with these furnaces to make them work, and so many disciplines. And it's exciting because you see all these disciplines come together
Yes.
and make the product work. And you get to learn a little bit about the various disciplines as well. So I think that's the most exciting thing about trying to encourage people to come to our industry, is let them know, look, you're not going to be sitting at a desk and just programming a computer all day long. You're going to find out how that program now interacts with this whole other system. And you know what? The next day, you're going to have another customer come around and he might want you to integrate into their system. So things have changed. So there is change. You're not going to get stuck and bored just doing the same thing over and over again. I think that's one way we can certainly attract new and young talent. As far as some advice for some other advice for these younger, the next generation, go to school, learn the fundamentals, take school seriously. It is a time to have fun. It's going to be the best time of your years, trust me. But take it seriously. I've always been told that you go to school to learn how to learn. Because that way, when you go out in the field that you're actually doing, you can apply those learning skills to whatever you're going to actually do. Be curious, ask questions. Those are important things. You will not know everything. You might think you know everything because you're young, but you don't know everything. We don't know everything for the time of our lives. We're always learning. We're constantly learning. And I think that's important that everybody constantly learns as well. The other thing I would say, Carlos, is be hands-on. Start on the shop floor. Get to know what it is you're working on. If it's a furnace that you're designing, go work on a furnace and run it. Load it with parts. Put in ramp rates and soak times and partial pressures and quench pressures, and take the materials out and hardness test them. Maybe you should learn how to do cross-sectional micro hardness testing. Learn as much about it as you can, because that's important to know as much about the product as you can. It makes yourself more well-rounded individual and a more valuable individual for the company as well. And lastly, I'd say be willing to accept change. We're constantly changing, and you can't just keep doing what you're doing. You have to accept change in today's world and embrace it.
Resilience. So one more thing, now that you're ahead of the company, let's talk about future ambition. Solar manufacturing continues to innovate, whether it's a new vacuum oil furnace or a solar backed control platform. Where do you see the biggest opportunities for advancement in vacuum furnace design in the next 5 or 10 years?
Well, I would say aside from the control systems, which we've already discussed, there's a huge opportunity for there as well. I see energy prices becoming a bigger and bigger issue.
Energy. Yes.
These furnaces, they run off electricity. They're not gas fired, but they're run off electricity, and electricity costs are going up. And to me, it looks like electricity prices are only going to constantly go up. So I see things that we can do to improve the energy efficiency of these furnaces in, say, the next 5, 10 years plus. So maybe there's different insulation packages we can have for a hot zone that run to maintain the heat, the energy into the hot zone more efficiently. So it doesn't take as much energy to heat up the furnace. Vacuum pumps, they're motors, they're running all the time. We need to be smart the way those motors turn on and how often they're running. Can we turn them off if we don't need them? Quench motors, there's another example where you may have, just for easy numbers, if it's a 100 horsepower quench motor, it costs about $7.50 an hour to run, using 10 cents per kilowatt hour as an example. Might not sound like a lot, $7.50, but okay, let's say it's running a couple hours a day, and you multiply that by a couple days a week.
Right.
Before you know it, you're up to thousands of dollars potentially of just one motor running. So look at ways to be smart the way we're running the furnace, help the operators not have to think about it, and use the control systems, again, all control system advancements, to turn off things when you don't need them. Save energy. And in turn, it'll pay off dividends in your electrical bill, which we see only rising. So certainly that's one advancement I see in the next 5, 10 years plus.
And I'm pretty sure we're going to see that furnace really soon under your leadership, under the Solar brand. Trevor, thank you so much for a thoughtful conversation. Your experience from hands-on R&D to leading one of the most forward-thinking furnace manufacturing is truly inspiring. Thanks for sharing this with me and the audience. And for those listening, where can they go to learn more about solar manufacturing or connect with you directly if they want?
They can go to www.solarmanufacturing.com or
Right.
www.solaratmospheres.com, solar ATM that is. And one thing you'll find on there is we have a lot of technical papers. We don't hide our technology under the basket, so to speak. We're open with what we have. So you can find a lot of good technical information on our websites as well.
Well, thanks again, Trevor, for sharing this with us. You are a power player of the industry now, a young power player of the industry now, but with a great future ambition. And for the audience, if you enjoyed this episode, don't forget to subscribe, share it with your colleagues, and stay tuned for more conversation with innovators and leaders in the world of heat treating. Until next time, Heat Treat Podcast. Trevor, thank you again.
Carlos, thank you so much. I had a great time.